Hey everybody, this is Larry. This is me going Q3 of the weekly contest 458, process string with special operations 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. To be honest, I struggled a lot with this one. I didn't quite know how to... let me go over my thought process for this problem, right? My thought process for this problem, honestly, is that I thought maybe I overestimated the hard difficulty, but I thought that I had to figure out a data structure, and I thought that maybe there's an idea around trees and just kind of almost like a compressed tree, if you will, as a way to solve this one. I think what ultimately got me a little bit of a hint, which maybe is a little bit weird, is that a lot of people solved this during the contest, and so I was like, oh, maybe there's a simpler solution, and then. And if you watch the live video, the way that I finally was able to do it, and I went for a lot of like thinking about trees and duplicating, but duplicating and then reverse means that like I was thinking about linked list and then maybe branching, and I think the way that I was thinking about was kind of like a GitHub thing, but or like not GitHub, but just like Git, right? In terms of like, you have branches and then you kind of remove them and then I don't know, but the reversal and also just removing it's a little bit funky because I was thinking about like adding different nodes and then having trees if you kind of duplicate, but then you remove past it, then you have to like a lot of edge cases. I think it's still possible, but it's just like very tricky to do. And I was thinking about it in terms of different like parse trees and so forth, and try to consider this as like a language in which we just have an expression, right? And try to figure out from that. Okay, but I mean the obvious thing. Let me go a step back. So those are the things I've thought about. Stepping back a little bit, the obvious tricky part is that K is really big, so you should not. So the solution that we have for Q1 is going to be way too slow, right? And yeah, that's basically the idea. So we have to do something much smarter. And it turns out the way that I did it, you could watch the live portion, and the way that I finally did it is just thinking, okay, maybe we can think about it forwards in terms of tracking, which I don't know why I tried to do. Yeah, I don't know, but you just have to think about it backwards. That's how I start looking. And I just kind of trace through the examples. I think for me, and if you want to see the tracing through example, you could watch the live portion, right? Because I did do it. But the thing for me was that I was trying very hard to think about I was trying very hard to think about yeah, I was trying very hard to think about how do you say it? Like I was trying too hard to think about it inside my head. I think that's what I want to say. Sorry for I have a brain fart for saying that. But in any case, my brain is not working well. But yeah, so yeah, I had to get inside my head and try to work out a lot of different data structures, try a lot of different things. And then when I finally traced manually, and I had a notebook, but I was like, oh, I could actually just do this because they have a deep explanation on actually all three examples. And I actually did go through all three examples. And then it's just going about it one by one. For example, this is K is equal to 1, then we look at the last character. And don't look at the current result, it doesn't matter. I just think about it in terms of buckets, in terms of like this is 0, this is 1, the A is 1, and then we move the last character. Well, the 1 index doesn't change from the last character. And then now we have reverse result, so then the index is still 1, because, well, it went from 1 to 1, but that's just a lucky thing from the end. And then append B, the index still doesn't change because it is a B, right? Though actually at this point I was like, oh, well, I actually went it off by 1 because I thought I was looking for the 0th. So I was like, oh, this is a B, this is the last character, so we should just return it. And then that's it. And then here, in a similar way, maybe this is a little bit better. Okay, yeah. This is a better example. I guess I am walking for it. K is equal to 3, so we have this D, right? And then we have a duplicate result. Duplicate means that, well, the first half is equal to the second half at this point. So if this is in the second half, then we just map it to the first half, and then yeah, and then we do yeah. So this one is going to map to here. This one is going to map to this one, right? And then this one, duplicate we sell. Let's just say we are tracking this one. This one doesn't change anything. The remove last character didn't change anything. Oh, actually no, remove did change things if it was this one. But yeah. So then this is just D. But if it's this one, then it maps to this one, then this one, and then reverse means that now this is the last character and so forth. So basically the idea is just go tracing through everything. And that's it. I think the problem, the other tricky part that I had was that I think I did a similar problem where you only have duplicate and add, and that one was easier to trace through because for each operation you know where the index is. The reversal and or even reversal would have been okay, but the removal, just one of the removals and reverse kind of threw me off, and then I kind of thought through it, and I just kind of, when I thought about it, when I was trying to think about it in my head, I wasn't able to come up with it. But when I actually, just demonstrated it out, I was like, oh, the only thing that you need is just the length of everything, right? And the way that we calculate the length of everything is just by going from the beginning to end. So this is, for me, maybe that's why it's hard, is that for this one, I have to do 2 passes, but in different directions. One pass to calculate the length, and then the reverse pass to go backwards. And I think I just had issue with just thinking about it in only one direction for a little bit. But once I did that, the implementation was not that bad, right? This is going forward, calculating the length, right? It is what it kind of looks like, yeah. And then this is what it looks like. Yeah, this is calculating the length. Hopefully straightforward. I have to go for it. If this is a star, then we remove, so we have a check. If this is a pound, then we duplicate, so length doubles. If this is a reversal, well, the length doesn't change, and otherwise then length just add 1, because then you have an alpha or just an alphabet and you add 1, right? And that's it. And then now we go in reverse. We zip it up. We have the current character and then the length. If the current character is removal, then K doesn't change. But also keep in mind that I actually probably should have put this here, inside here. That's basically the thing, that if we remove it and K is outside the bound, then we just return period. But this already happened, so that's why this doesn't change that we could pass. Otherwise, if it's duplicate, then we just check if it's in the first half or the second half. Keep in mind that if this is duplicate, then L is always even, so we don't have to check for it, and we just do this. Otherwise, this is a reverse, and this is the part where we need the length. And well, I mean this too, but you could have maybe implicit out from the number of previous duplicated operations or something like that if you didn't have this. But in any case, yeah. So then here we just reverse it by taking the length, and then we just reverse it, based on that. And then if we add, well, K doesn't change, so we have this thing, doesn't matter. But if it is equal to L-1, then we just added this character. And because we just added this character, we just return it. And that's it. Pretty okay, right? This is going to be linear time, linear space to the L. Though you should probably, I think now that I think about it, this could get a little bit wonky because of the times multiplied by 2. The reason why it doesn't time out is because, well, 2 things. One is that Python has big nums, and that kind of saved me. Obviously, it doesn't overflow and messy, right? So that's one. But then the other reason why it doesn't time out, even though it overflows a lot, is because the biggest number is going to be the number 2 shifted n times, where n is 10 to the 5th. But if you amortize it, actually no, that's well, I think I just got lucky. Yeah, I think I just got lucky. Maybe it is something with this, with the will not exceed. I mean, in theory, you could go over, but then if you have to subtract, then yeah. So maybe I just got lucky, actually. Maybe. because then current would be at most, that's only at most 10 to the 15. I think, okay, so maybe that's the real reason, my apologies, is that, and we also use, I guess the big num thing doesn't really come up, actually, because you can even assert that you cannot, because my idea was that you can double, 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 and then go under it with some subtraction, but you don't have that many subtractions, so I think that's basically it. And that's it. This is linear time, linear space. Hopefully, and this is the bottom. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live in the contest in 2 parts next. Okay. Didn't misread it. It was very easy to misread. Well, I just kind of probably rushed that one a little bit. I didn't really, it took 3 minutes. This still takes time to update. I don't know how long, but 3 minutes on that one. Okay. Now we have 2 hearts. I always look at the leaderboard, but it's for pure cheating. I always forget. Okay, so this is Q1, I think, but except for with an integer k, string of the final. Okay, because this can be really big. K can be pretty big, and I guess it can also be pretty big. Okay. How do I want to think about it? I mean, it's just keeping track, right? But it is awkward. Just a pen. I mean, it's just the algorithm is simple. Is it easy? No. The algorithm is simple, but the implementation is a mess for models like me. How is there a period? Oh, it's out of bounds. Okay. Okay, I mean, there's at most 10 to the 5th, so that means that there's only at most 10 to the 5th unique thing. So maybe it's not just tracking. Maybe we just need a better data structure, like a tree type thing. Because we only duplicate. But it's duplicate, and then we. All right. How would I think about this? Okay. If C is equal to the. I don't know how to reverse this. Let me think about it. Also, this seems like a problem where Q4 is easier only because it's a graph thing, and this is maybe the idea isn't that easy. Maybe there's a trickier way. Because the removal, if it wasn't for removal, I think this is pretty straightforward. The removal actually messes me up. Maybe not. Maybe not only that, rather. Okay, so let's say there is no duplicate. Then is this easy? Maybe. Right, because it's just remove and add, remove and reverse. So then duplicate. And we only duplicate 10 to the 5th times, which is, well, only duplicate 10 to the 5th time. Well, we can remove stuff. How do I write this? Previous way tree, but I'm trying to think of the clean way of doing it, or even just a way of doing it. Remove and then add, and remove and then add, which is very funky. Because you can remove a lot. But is it the way to, is tree the way of doing it, or is it just maybe it is just tracking? Okay, if we ignore reverse, the reverse is weird. No idea how to do this. How do I? Cave character. Oh, that's nice. I don't really have any good ideas. I'm trying to think whether there's a way to do it such that the length of the processing will not. So, what is that? So there's only 30 duplicates. So maybe we can do something funky with that. Because there are not that many changes. The only thing that's weird is the doubling. So I guess it is just probably keeping track of indexes. But how? I mean, there should be only 10 to the 5th, right? So, okay, let's see. Let's think. Okay. What does duplicating mean? Can I think about it in terms of frequency tables or index lookup? What does reverse? I don't think that changes anything. You just Duplicate. This is tricky. I'm gonna come back to this maybe. Well, actually, looking at the way few accepts, maybe this is easier. Even if there are a lot of people cheating, that means that people find this one more doable. But how? I don't really even see an easy way to do it. I mean, maybe it is just tracking. How do I do it? What am I tracking? So, okay. What if I do something crazy? If the C is lower, then, you just keep going. Or something like that. It's not quite right, but it's fine. This notation. But then what does that mean? Okay. I mean, I guess we have to do it, and then else if C is equal to then current.pop, right? But then how do we do? I guess we don't need continue, but I just keep on doing it a bit. Can I do it with a doubly linked list? What does that mean? Can I do it with linked list? Then you can just do modify. I mean, well, it's not linked list. Then it'll just become like a edit, like a tree of sorts. If I keep on doing it that way. But still, you gotta. And each node can represent multiple indexes. But how does that help? 3,000 people, 30% of people solve this? Are people so good? And I'm just bad? And maybe. Does this help? Or is it just a not overflow thing? Because the problem is this is so hard. Because you remove and then, or reverse and then duplicate, makes it like crazy. Hmm. I mean, this is going to be less than 60. I mean, it's not a lot less than that, but 50? Is there a data structure I just don't know about? A lot of people solved it. Or maybe it's just searchable. Maybe this is a known problem. But, don't even have any idea on how to structure this. That's the crazy part. Maybe I have to come back for it. Alright, how long have I taken? Okay, so I took about 20 minutes. So I still don't know how to do this one. We have 45 minutes. I guess for each index we could look at the parent. Can I think about it in terms of a tree, an implicit tree? What happens when you double? I need to draw it out. I tried to. Sometimes I always forget that I can just draw it out. Sorry, friends. I'm using my drawing pad or my notepad. Okay, so let's say we have. Okay. Let's say we just duplicate a lot and then subtract and then duplicate again. And what happens? Can I track it that way? Let's just say we have 0. Okay, let's just say we have 0. We can track it by after every operation, maybe? Can I do it that way? Because we only need to keep one copy. Maybe, I don't know, that's not right. I'm still stuck on this tree idea. How much time am I? 41 minutes? Ugh. How do we keep track of the length? Can we use that? And we can figure out. Can we figure out? I don't know. Okay, let's say we have length 1, 2, 3, and reverse. We have to do some reverse math, and then 2. Well, reverse is easy with the index, right? If we just have to keep track. Okay, let's say k is it k 0th index? No. Okay, so let's say we want the first index. 0, duplicate, okay. Still looking at 0. Still don't know how to handle the dupes. Can I work backwards? Okay, so we want the first character here. And the first character here, we move the last character. Okay. Then reverse. That means that now we go to the last character here. And then append B. Then it should be B then. And then we can even return probably. Well, we don't know what it is. Oh, now we do because we append B just by itself. Right, yeah, I mean, okay. Maybe that's a weird edge case. Let's see, k is equal to 3. Work backwards then, right? So 3 or 2 index, whatever. It's gonna be D is here, right? 2. Okay. We see a duplicate, so that means that well, duplicate doesn't matter because the duplicate is on that side, so we just go back to here, keeping track, so the same index. We move the last character, same index. Duplicate result. Then now this one is going to be the 0th index. Reverse. Oh, the duplicate result, yeah, okay, this is on the later half, so this is okay. On the 0th index now, 0th index, reverse result. So that means it's the last index. So you just have to keep track of the length on each one. Let's try again. Well, this is just how it bounced. Okay. Okay, maybe I have this idea. I don't know if this is right. But I think we can, yeah. Okay. I mean, I guess this is what I was saying that we need to do, but I just couldn't figure out the length. I think the idea is maybe just keep track of the lengths. Yeah, okay. Let's see. What is it again? Okay, removes. So, okay, so if current is greater than 0, current. Okay, else if current is star, we duplicate it, so that's current times 2. And then else if C is equal to pound, we reverse it, which is no change. Else it's a pen, so that increment by 1, and then we just got a pen current. And then we can just now go backwards. How do we go backwards? So for C and something like that. Okay. Right. Maybe we could even zip it with L. Something like that. Then C, L, and then we just manipulate K. Okay, fine. And then we want if K is greater or equal to L, then we just return dot. Is that right? Maybe. Well, hopefully. Okay, then now if C is pound, then I guess it by definition has. I wanted to check for odd evenness, but I guess it should always be even if it always the last thing was duplicate. Also, that's not the duplicate. Man, I am confused. I don't know why I look at it. Okay, let's look back here. Remove the last character. Okay, remove the last character. If K doesn't change, right? But if K is now, do I have this right? I don't know if I'm off by one. I think that's the thing I have to think about. We still have 34 minutes, so maybe it's okay. I don't know. Let's just pass for now. If C duplicate, then now if this is afterwards, so okay. This is after the change, L is after the change, so maybe we can, so this would already be checking what we want to check. Now it's duplicate, so then we want if K is greater than or equal to L divided by 2. It's slightly more expensive than multiplying by 2, but that's fine. Okay. Then we track, oh, not that's sort of 1, Larry. That would totally suck. Okay. And then if it's on the left side, doesn't matter. Okay, fine. And then we have, if it is reverse, then now this is something like K is equal to L minus K or something. -1 probably. And then it's a character, so we add a character at the end. K also doesn't change. Then how do you return? I mean, okay. If you add one to the end, of course, the K doesn't change. This is a little bit awkward. Okay, I think this is what the magic is, but I think I missed this part. Okay, so here the length would be 3. K doesn't change. Okay, fine. But if K is equal to L minus 1, maybe? Or L plus 1? L minus 1? Maybe this way is wrong. Okay, let's just return. Okay, we need the index to that matches this length. Oh no, that's the C. I am dumb. Then we just return C. Maybe? And then we'll just sort of force for now. I think maybe there should be a period, but okay. Well, it's good that this assert only on the last one. Oh, that makes sense. Okay, so 0 of this, But wouldn't this already be okay? Let's print zip SL real quick. You just give me iterators. Okay, fine. That's what I was guessing. Okay, Z1, that's afterwards of 0, 0. So then now it's going to be pound. But this, what? But K is 0 and length is 0. So then why would it just not return period? Huh? L, okay, fine, K. Then this, oh, K is negative, oh, K is not 0 indexed. Or not 1 indexed. What? When they say K is very confusing. I always think it is 1 index. Okay, fine. Okay, I'm just being dumb. Okay. That's an easy fix. If right, AD period. Alright, well, that actually looks okay. I don't know that, I mean, it is okay for me to put that, but I feel like I'm gonna get lucky. It may be wrong, but I want to get lucky. I have to remove some printing statements, don't we? Where's that a print? Okay, here. I don't know how confident I am. YOLO. Oh, huh. I can't believe it took a while. I don't think I guess you just have to keep track. I think I got stuck on. Yeah, this never happens. Second, I got stuck on trying to think. I was still thinking of some tree thing. Maybe I should have just. I don't know. I mean, I thought it would be harder to keep track, but I just didn't really think about keeping track of the length as we go. I think that was the hard part. Once I did that, I guess it was okay. Really struggled with that one though. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this problem, this video, this contest, everything in between. Stay good, stay healthy, to mental health. I'll see y'all later and take care. Bye bye.